Hello, my name is Denis Mishinov. I'm staff front engineer on the AI framework team, and in this team we believe in accelerating the new ideas to enable more teams and individuals to come up with new creative AI features quicker and easier. Welcome to the second video in the Easy AI Experimentation series, where we discuss how to play with AI and evaluate AI ideas and experiments before implementing them in GitLab. Actually, even before creating any POC. So in today's video, we will evaluate exactly the same AI idea we had in the first video, but using different tools. For those who don't remember, we evaluate a potential GitLab feature that would help answer the questions of the "is this known" type. In the first video, we talked about how to evaluate the idea without even writing any code using Google and Anthropic models and consoles. Today, we will still pull in the actual data from GitLab API, just like we did in the first video. We will use it to contextualize our conversations with the LLM. However, we will extend it to storing the data and reuse this data without pulling it from API every single time we need it. We will also cover somewhat more advanced prompt engineering. We will talk about vector storage, and by the end of this video, some of these things might even actually start making a bit more sense. And for those among us who really like hype, today we are going to do RAG, or Retrieval Augmented Generation, but more on that later. The main point is that as a result of today's video, once again, we will get a working idea evaluation for a potential GitLab feature, but this time without all the context switching as we had in the first video. We'll sit in the same environment in repeatable, shareable, and versionable manner. So let's get straight to business. Let me introduce you to the AI Experimentation project. I know the name is not really exciting, but naming is hard. So what's this? What's this project? Technically, it's just a playground for AI experimentation. It is powered by Jupyter notebooks, and for those who are not familiar with what Jupyter notebooks is, it's just a way of documenting different things like features, in this particular case, combining code and markdown, explaining what that code does. So it's kind of like documented coding environment. But the really cool thing about the Jupyter notebooks is that it comes with a web server, which allows the code snippets in those documents between markdown texts to execute those code snippets right there in the document. So, which technically means you will see the result right in your document instead of just running a script every time you want to do some changes. That's pretty cool, but we will take a look how it works in a bit. So let's just start by cloning this repository and running the installation process. So I have cloned the repository into the AI experimentation folder. We have README experiments package, and let's go to the website and check the README. So the project has the prerequisites, and it's technically just Python. If you are a front-end engineer or UX designer who knows front-end, please do not run away now. If you want to run this project in Node environment, in JavaScript environment, it is possible. You will just need to install this Dano environment, which does provide the kernel for Jupyter notebooks to run the code snippets, to write code snippets, not in Python, but in JavaScript or TypeScript to be precise. How cool is that, huh? So I do have Python. Let's check this out. Python -v, and I also have installed Dano, but if you probably you don't have it yet, so you might want to go to the linked installation guide, and I chose the ASDF installation method. If you want, you can pick something else, but let me just check this out. ASDF list. So yes, I do have Dano. It's 142.4. Wonderful. So I'm done with the prerequisites. Let's go to the installation. Clone the project repository to your local machine. Yep, done. Run pip install requirements. So what this will do, it will just install all the Python requirements or Python dependencies in one go. No big deal. If you have Python, it should go pretty smooth. There is nothing fancy as a dependency for this package. Good. Now we go and optional for node environment. We will try node environment. So we just run npm install. npm install. Straightforward, easy. While it's running, install the Jupyter kernel for Dano. So this is the part that we need to run. In quick start, we technically have to run Jupyter, this command. It assumes the Jupyter command is available in your path, and after we run the first one, where install requirements, Jupyter, we have to make sure that Jupyter is available in our path. So it is. So it is interactive computing, as it says fancily here. So wonderful. Let's just install the Dano kernel for Jupyter. Right. No Dano execute. Right. ISDF install Dano 142.3. Probably that's what I need to do. Right. Let's do like local Dano. Oh yeah, local Dano 142.3. Yes. Now Dano. Okay, we have Dano now, and now we can get back to installing the Jupyter kernel for Dano, and that's it, done. So we are done with all the installation. That's it. That was it. Now launch Jupyter Notebook in the project directory. We are in the project directory, so let's just run Jupyter Notebook. And what it does, it runs the Jupyter and launches this web server that I told you about, and it gives you the folder structure of the project you are in. So experiments, node modules, package log, package JSON. Let's double check that that's exactly how it is. So experiments, node modules, readme, package requirements. So that's it. And now this package comes with one particular experiment already in place. And guess what? It's exactly the experiment that we are about to build today. But to speed up the things, I've already built it here, and we will just walk through these through the existing notebooks here, so that you could see how things are built here. So all the experiments of this project will be within this experiments folder, and there is this known experiment which we were talking about, and there are two folders here, Python and Node. As I said, we can run these Jupyter notebooks both in Python environment and in JavaScript or Node environment. And I will be honest with you, Python environment is a bit easier. A Node feels a bit of an afterthought. So not everything is as simple as in Python. So for the purpose of this process, we will get to the Python, but I will also demo the JavaScript. Keep in mind that this experiment has README file. Let's go to this README file in the repository, and this README explains what this feature is about, what's the idea, and then potential integration points. This is great to have this, to sort this out when you will communicate your idea or your experiment to your peers, to your EM, to your PM, to upper management. So it's always great to explain the rationale behind what you're doing. So let's get back here and open the Python environment. There are two things here. First notebook is called setup storage, and second notebook is called tool. The first one we want to look into is the setup storage. And as you can see, it looks like some markdown, right? So technically it is markdown, but with some code snippets here. And as I said, since Jupyter comes with web server, it allows these code snippets to be run. So it always focuses on the first field. The first field is markdown here. So you just press Shift Enter and it starts jumping or iterating through the fields. And when it gets to the code field, if you press Shift Enter, so this means execute this cell. These blocks are called cells in the Jupyter notebooks. It will execute. You see this asterisk, so it means this step is being executed, and it outputs the result of this execution right here in this document. How cool is that? Once you see the number here, this means that this was the step 1. This means that this step is done successfully. There are no errors here, so we can continue. Shift Enter. The interesting thing is that all the things are documents. So it is the self-documented development environment. In the first step, we technically installed all the dependencies that we already have, which were installed from this pip install requirements txt. So here are these requirements that we just install. Where is this? Install here. That's the same. So now we make sure we load our secrets from the local.env file. When in first video, when we were playing with LLM in the consoles, either for Google or Anthropic, access to those has already been guarded by some API access, access token or some level of access allowance to those services. When we work outside of those contexts, we have to authenticate ourselves with the means specific for that or another environment. There is the point about this in the README authentication. So every experiment environment expects to contain .env file containing secrets like GitLab path API key. Yes, in order to get to a GitLab API from this environment, you will also need to have the path. So you have to have the keys to access an LLM, blah, 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 blah. And you just go and depending on the models that you want to use in your experiment, you just need to authenticate for that or another provider, for Vertex or for Google or for Anthropic. So this is great. And since we are about to hit this path where we expect .env, we can, just for the sake of it, we can start Shift Enter and see what's going on. It returns false. This means that it couldn't find this file, this .env file. So I will go on and add these files. I copied or I created .env file both for Python environment and for the Node environment. And just to make sure we have this, we go to the experiments. Is this known? Let's go to Python because we are running Python at the moment, and then we do have .env variable containing API key to access to get to the Vertex API, and my private access token for GitLab in order to fetch data, as we did it in the first video. I have authenticating myself to the Vertex using Google CLI, but this is again just check the parts of the authentication and access to different services beyond the scope of this video. So we have the .env file, so we have the variables. So let's try to rerun this step now. Again, while still staying on this cell, we should just press Shift Enter, and it was running the third process. So it was second process and third process, but now it returns true. So it was able to pick up the data from .env file and load this information into the working environment. Then we get to the interesting thing. This project is driven by Llama Index. This is kind of the framework to build your AI applications. And by default, Llama Index sets up both as text processing model and as embedding model. We will talk about embeddings in a second. It sets OpenAI models, but we don't want to use OpenAI here. We want to change to the models which are available to us. As you might remember from the first video, we've got the best textual result when using Anthropic, and in particular Claude 3 model. So in this particular case, we have Claude 2.1, but we'll change this to Claude 3 now in a second, probably. This block is about setting up the models. You update the settings of Llama Index saying, okay, for my textual model, use this model, and for my embeddings model, use this model. In this particular case, we can combine. This is something that was not available to you in the provider's console. Here we can combine. We can take the textual model from Anthropic, but the embeddings model from Vertex, from Google. And we combine those in the same application. And it's going to be the same possibility when you implement this feature into GitLab. So this is great to play with different combinations, different models. In this particular case, as I said, we point to Claude 2.1. This is much less capable model compared to Claude 3 Sonnet that we tried in the first video. But for this particular step, Claude 2.1 is totally fine. It is enough. We do not need to deal with updating it here. Claude 2.1 is probably cheaper to use than Claude 3. So, and for this particular step, which is setup storage, we'll talk about what that storage is in a second. Claude 2.1 should be totally fine. Now let's go to the next. Actually, we need to run this step again. You see, there is no number here, so this step was not run yet. So Shift Enter. It is running. It is running, and it is still running, and it returns the number. So it was successful. Now we get to this very interesting thing. Before we get there, let's just fold this 1.1 step to not disturb us. Not to distract us. So step 1.2, set up data store. This is where we get to the really interesting thing. This is where set up storage title might make more sense now. And this is where our embeddings model that we picked Vertex for that, where it will start making sense. So what is the data storage? When working with AI, you probably have heard the term vector storage. This is the numerical representation of different text chunks, like in a very, very basic approximation. This is just about numeric representation of text chunks. And then special embedding models like Vertex that we are using, they take text, digest it, and spit out these numeric representations. Why to do this? Searching information in these databases in these storages is much quicker than searching for textual representation. This will allow LLM to this embedding model to build to easily build similarity between between your prompt and different textual information represented as numbers in that vector storage. So for this purpose, we built the vector storage in order to speed up the process. Remember, getting the answer from Anthropic took a while because we just pasted raw dump from our API into the context, into the system message of Anthropic console. In this case, we will dump this into the vector storage. This supposedly should increase the speed of our solution. But we do not want to deal with complex vector storage to connect several storage like real databases for vectors. In this particular case, our data store will just be the folder on our hard drive. That's where we will dump all the numbers, and that's where we will retrieve them from when we need to get information about those issues that we store there. So, and this step is exactly about that. So Shift Enter to go beyond the markdown cell and get to the code cell. Here we just set up the storage context and we point to the folder that will serve as the storage context. For evaluation and experimentation, this is more than enough to store things on your hard drive. So it went smooth. There are no hiccups here. And here we come to the interesting part. This is what we did in the first video. In the first video, I used Postman to dump the issues. I can it was just the API call to issues API of the VS Code extension project, and then we got the list of issues. This time we technically are supposed to do the same thing, just with the Python means and a bit of things like checks to avoid any errors. So there is nothing fancy here. Remember, we loaded the content of our .env file in the beginning. This is where we get it. We get GitLab private token from that env file. We raise the error if there is no property like this in .env file, and then we specify the URL. It's exactly the same URL that I took from my Postman for the first video. We just create the request, and then in the response we expect some documents, the list of issues. If we don't get, we spit out the error. If we do, then we just set the response documents variable with a JSON representation of the data that we've got. Let's just it's pretty straightforward, very clear to understand, I guess. So let's just run Shift Enter here, and it passes totally fine, no errors. So we are supposed to get the response documents here. Let's figure that out, whether we actually have anything there. And now you will understand how cool is that. So we need to add the cell right after this one. We just click plus here, and this is going to be the I'm not sure whether it's a code cell or not, but let's just try this. Print, no, it might be response documents. Yeah, so let's try running it so that it will print us the response documents that we got here. And yes, we do have everything. How cool is that? Like, you can debug your applications right there in the web browser, get the results right here. But there is a cool thing. You do not have to use the web environment. VS Code does support Jupyter notebooks. And you know what is cool? You see, we have this print documents and then this output. This web server, which runs this Jupyter notebook, syncs it with the hard drive. So if we open this project, Code Insiders, in VS Code, this particular folder for Python, and go to the same file that we are looking at, it will contain all the outputs that we've already gotten, including the additional part that we just added to this notebook and the output. So technically, you can switch between the environments, and you can work in your IDE without even leaving it. I just prefer going to the web because, I don't know, why not? If you prefer continue working in VS Code, that's great. I technically do this, but it is a bit light here, and I prefer just lighter colors to not fall asleep while I'm recording this video. So we see that this works, right? So technically we don't need this. It was just to check that we store what we need. So we can delete this cell. It is deleted with its output, and guess what? It's gone from the VS Code as well. So last checkpoint, so it technically stores different checkpoints while you're working here. So we concluded that this step ran, it was fine, successful. Now, this is the tricky part. We get the data as just an array of JSON objects. This is the representation of the issues that we get from the API. In order for them to work with the Llama index, which is technically the engine the framework which provides us with different convenience utilities and abstractions here, we need to convert those documents into the Llama index document. Don't worry, it's super straightforward. You see a lot of lines here, but not because we have to. Technically, the only part which we are interested in is just this part. So for every issue in that array, you create a document entry, and you could pick different way of splitting. You could say that the whole array of things is one document, but then it will be harder for LLM to consider. It will technically be exactly the same situation as we had in the first video, where we dump the whole array as just one solid thing. In this case, we can split the array and get every issue entry as a separate document, which will supposedly increase the efficiency of LLM and will provide us with faster and more reliable results. So what I do here is, for every document in our response documents that we have gotten here, we just take title, description, and web URL. We also convert everything else into the metadata, everything which is not title, description, and web URL. But what we really are interested in is title, description, and web URL. That's technically how it works, but we do even more. In order to help LLM, we get everything like title, description, we clearly mark them in just one long string and mark it as text. This is a parameter that is required to be passed to document. And then ID is the web URL. These are just some small tricks in order to make LLM more efficient and help LLM find the required information much quicker. But again, you do not need to do it on this granular level. Nevertheless, that's here for you to explore and to play with this. Let's run this cell. Shift Enter, and it went really quick to split all those response documents in the Llama index documents. Was really quick. Now, initialize an index from the parsed documents. This is where we actually create where we vectorize our documents. Up until this point, all the documents are still presented as the textual information, technically representing our JSON. At this point, we will initialize the vector store index, which again will point to our local folder that we initiated in step 1.1, I think. And we'll convert all the textual data into the numerical representation and dump into that storage. So let's try this and see how it looks like. It also provides some progress bar saying how many textual nodes it parsed and how many embeddings it generated. So embeddings is actually this numerical representation of the textual information. And now at this point, we can go to our folder, to our storage folder, and then we will find image vector store here, which is oh, right, okay. Where is this? Right, here is the default vector store is the thing that I was looking for. So these are the embeddings. You see all these numerical representations. Each of this represents a chunk of textual information. Nothing fun, like nothing really exciting here. The reason why I show you this and explain this to you is because somebody might have a question, why do we do this? But that's technically the reason. We have to dump this into our local storage on our file system, and that's pretty much it. Otherwise, we're not very interested in this. So with that out of the way, we can get to point 1.6, and technically we can fold this one. We won't fold these parts, but we get to initializing an index, and now we can get to the next point, 1.6, where we create a query engine. This is technically where our last step of creating a query engine out of those embeddings, so that we create the we technically create the way of querying information from those embeddings, from those vectors and numerical representations. So, and now we can ask a question. So let's do that. And in order to test whether we have gotten any information there, we do really simple check. I send a query, what issues with dual chat are you aware of? Remember, we have dumped information from VS Code project. It's much more than dual chat, so it has the mix of issues there. So I'm just curious to see whether it picked any dual chat issues in this process. So let's run this. Shift Enter, so it's running, and it will print out the results once the results are here. Let's see. Yes, so here we go. Let's remove this cell. We don't need it. Based on the provided context, and there are two issues here. A message with a visual contrast in the feedback modal alert, and then a feature request to add speech to text support. Okay, sounds good. So these two issues are part of the current context. Super stuff. With that, we can conclude that what we did here was we've got an opportunity to set different models for textual representation, for embedding. We have created the embedding storage. We have created the vector storage for our textual information. We've pulled the information from GitLab API. We vectorized it, put it into the vector storage, all on our file system. And then we've got an opportunity to query that database of information. Imagine using this not only for GitLab, but let's say you can put, I don't know, 10 books into this storage, and then just ask the question about those books. If you want to understand something or some help writing an essay or anything like this. This is a really neat way of doing the things. So we have created the query, and at the end we have created the query engine, which we queried and confirmed that there is an information stored in this vector storage. The interesting thing here is we can collapse this. So the only thing that when you work with Experiment in this project, in this sandbox, the only two things that you probably want to play with, to change, are these two cells. What data we load from the GitLab API, and what do we do? How do we convert this into the Llama index friendly format? These two cells are the most important ones for you to take a look, apparently. All the rest can stay the same for you to just consume. If you want to play with the models, you can go to where is this? You can go to this step and play with the model, switch the model to see how it will affect the end response. But keep in mind, when you query your vector storage, you have to query it with exactly the same embedding model as we specified here. We will get to it at the next step in the next video. But for now, remember that you can play with the textual model in different implementations, but if you want to connect to a vector storage, you have to connect with exactly the same model that storage has been created with. Now, we created this storage in our Python environment. And the cool thing about this is that in the next video, we will be able to query it without getting to the API. We already have the information. We will reach out to the storage just like we would do on our hard drive, and we skip a lot of steps for contextualizing our LLM. But we will talk about this at the next step. Before we wrap this one up, let me demonstrate you the node environment. I said that you can write node and work with node environment. So let's open exactly the same notebook in the node folder. It has exactly the same titles, the same markdown, but it's just working with the TypeScript instead of Python. You see this little Deno label here. If you go to the Python, it will say Python 3. It indicates the kernel that this particular Jupyter notebook is working with. It runs on exactly the same web server, but with TypeScript environment. So you can, for example, still run Shift-Enter, and it will just do exactly the same thing. It will show you what is going on and what steps are in the process of being run. In this case, it spits out the OpenAI embedding. Here I'm using actually OpenAI embedding, which is totally fine for public textual information of the issues, because probably it was already trained on that. But this is technically exactly the same as in Python, but written with TypeScript. It will be easier for front engineers and UX designers probably to get this information rather than playing with Python. However, if you will give it a try, I bet you will like the simplicity of how Jupyter notebooks are run in Python. There is one thing when you work with Deno kernel in Jupyter notebooks. If you import from node modules Llama index, for example, you have to prefix it with npm colon. This is just to tell the kernel that this is something local and it needs to get to the node modules folder. Not a big deal, just something to keep in mind. And then it's technically the same thing. The interesting thing is that if you would use the same embedding model, you could create the vector storage in Python and then query it from this node environment if you use exactly the same embedding model. We will talk about the next steps in the next video, but for now, let's wrap this up. Again, to sum it up, today we were able to use this AI experimentation project to play with Jupyter notebooks. We installed the whole project, we installed all the dependencies, we started the Jupyter notebooks web server, and we played with the Jupyter notebooks, outputting information right away, real time, and we were able to query information from a GitLab API, create the vector storage, put this information into the vector storage and query that vector storage right from the same environment in our browser. Or, as I said, if you prefer to work with VS Code, you can do it in VS Code. See you next time. Thank you.